Imagine standing in a dark room. Your hand reaches out, finds the familiar plastic rectangle on the wall, presses the switch, and in an instant the room fills with light. That brief, everyday action hides a cascade of invisible events, an elegant choreography of physics, engineering, and human invention. Tonight we trace that chain, from the simple click beneath your fingertips to the warm glow spilling from the bulb. Begin with intention. You decide you want light, and when you press the switch, you change the configuration of an electrical circuit. A switch is not magic, but a controlled interruption. In its simplest form, it is a gap that can be opened or closed. When closed, it completes a path for electricity to flow. When opened, it creates a break and halts the flow. The flip you make repositions metal contacts inside, bringing them together or drawing them apart. That small mechanical movement is the trigger for everything that follows. Turning to the source, most homes receive alternating current delivered through a network of power lines. Behind your walls, live and neutral wires run from the main supply. The live wire carries voltage and electrical potential ready to do work, and the neutral wire offers a return path. The switch sits in series with the live wire. When you close it, you allow current to travel from the supply, through the switch, along the circuit, into the lamp, and back again. The switch is the gatekeeper. Its job is straightforward but critical. It must handle voltage safely, ensure a reliable connection, and minimize wear over many cycles. Inside the switch, when contacts meet, electrons begin their journey. They do not race like marbles down a slope. They drift under the influence of an electric field at a modest speed, while the field itself propagates nearly at the speed of light, signaling charges farther down the wire to move. This is why a light comes on almost instantaneously. The bulb is the destination, and different bulbs respond to current in different ways. Consider the incandescent bulb, a classic example. Current flows through a thin tungsten filament, encountering resistance. That resistance converts electrical energy into heat, raising the filament's temperature until it glows, emitting visible light. Incandescents are simple, but they waste a lot of energy as heat. Fluorescent lamps and LEDs operate on different principles. A fluorescent lamp excites mercury vapor, creating ultraviolet light that a phosphor coating converts to visible light. LEDs rely on semiconductors. When electrons cross a junction between materials with different electronic properties, they release energy as photons. These technologies require additional components ballasts for fluorescents, drivers for LEDs, that sit in the circuit and condition the current. Safety systems and design details are woven into the wiring that follows the switch. Fuses, circuit breakers, grounding, and insulation protect against overloads and faults. The neutral wire is often grounded at the service panel, so the system has a defined reference potential, and outlets and fixtures are connected with care to prevent shocks. Modern switches themselves may include features like dimming controls or smart modules that communicate with home automation systems, but their fundamental role remains the same: control the flow. Switching also introduces opportunities and challenges. Rapidly interrupting current in inductive circuits can produce voltage spikes, so switches and protective devices are designed to manage arcs and surges. In industrial contexts, heavy-duty contacts, arc chutes, and timing mechanisms prevent damage. In the home, standardized wiring conventions and codes ensure that anyone flipping a switch experiences light without danger. Finally, there is an elegance to this everyday technology. What feels instantaneous is the result of careful engineering, power generation and distribution, safe wiring practices, materials science in filaments and semiconductors, and the humble switch that translates human intent into controlled electrical flow. Each click is a tiny demonstration of cause and effect, rooted in physical laws and human ingenuity. So, the next time your hand finds that switch, pause for a moment and appreciate the unseen sequence it begins. A simple flip completes a chain that stretches from power stations to photons, one small motion that turns potential into illumination.